In this small video, I will talk about Pascal triangle and its property and hope that you'll be aware of some analytical processes that are connected to these properties. So let's get started. The Pascal triangle, also known as Tratagle triangle, can be represented in the form of combinations or in a numerical way. So, regarding the properties of the Pascal triangle, we can register that the combinations of n chosen 0 is equal to the combinations of n chosen n. This is revealed by the fact that each row of the triangle begins and ends with 1. Another property that we can see is established by the equality combinations of n chosen p is equal to the combinations of n chosen n minus p. And in this case, it says that this triangle is symmetrical in the sense that equidistant terms from the extreme are equal. So let's see another property. And it says that the sum of two consecutive terms in a row is equal to the element in the line below. So by adding two consecutive numbers in a row, we get the number placed among these in the following line below. Another property of the Pascal triangle gives us the sum of all terms in a line is the power of 2, specifically 2 to the power of n, where n is the order of the line in question. If we number all the lines in the Pascal triangle, we must note that the numbering rows of this triangle starts at 0, so we have a direct identification with the number of elements that are combining, and this is in line 0 we have n equals 0, in line 1 we have n being as 1, and so on. So, if you look at the interpretation of this property, we have in the 0 line 2 to the power of 0 equals 1, and in line number 1 we have 2 to the power of 1 equals 2, and the sum of the elements in the second line is 4, and 4 is 2 to the power of 2, and so on in every line until, generally speaking, we have the sum of all the elements is 2 to the power of n. Quickly, we may count that in any row, let's say in the nth row of a triangle, we have n plus 1 elements. Let's say it's easy to count that every line has one more element than the order of the line. So let's see some examples, and in the first one we have 3 questions. Well, starting with the sum of the two last elements of a row in the Pascal triangle equals 13, let's see what the biggest element of this line is. Well, as the two elements of one row in the Pascal triangle are equal to the first two elements, we can say that combinations of n chosen 0 plus the combination of n chosen 1 equals 13. So being the first element in the row and the second, we have 1 plus n equals 13, and in that sense we have n equals 12. So being at the 12th row we have 13 elements. The greatest element is the middle one, that is combinations of 12 chosen 6 at a time, and this is 924. You can easily get to this number using your calculator or even using the expression that gives the combinations of n when chosen p equals n factorial dividing by p factorial x is n minus p factorial, and in this case it is 12 factorial dividing by 2 times 6 factorial. So getting to the second question in this example, what the fourth element of the next line? Well, if we are in the 12th, the next is the 13, and the fourth element is easy to get, that is 4p equals 3 in every row is when p equals 3, and in this case combinations of 13 chosen 3 at a time, and we have 286. And the last question here is what the sum of the elements of the previous line is. Well, if we are in the 12th row, the previous one is the 11th, and so the sum will be given by 2 to the power of 11, that is 2048. And for a last question, consider two consecutive rows in the Pascal triangle of which we reproduce some elements 28x, 70, 84, y, indicate the value of y. Using the property that the sum of two consecutive elements in a row gives the other one just the row below, we have that 28 plus x equals 84, and on the other hand, x plus 70 equals y. So in this case, we have just a system of two equations to solve, and in this case we get x equals 56 and y is 126. Well, before going, I would like to give you a challenge. Consider these two consecutive rows and please register these rows 28, 56, 70, 84 and 126. Okay? Then, what are the row numbers shown in this scheme? Try to discover this through an analytic process. Hope you have enjoyed it, and please get your hands on the job.